All right. So, hello and welcome everyone. So, we are live right now. Welcome back to this amazing platform of Tutee learning. And I hope I'm audible and visible to all of you, right? So, yeah. So, welcome back to this amazing channel on Tutee learning. And we were discussing about definite integral, right? So, in this lecture 6 of properties of definite integrals, we're going to discuss about the properties and the last of the properties or the last very few properties are remaining, right? So, if you're into this particular channel, please subscribe to the channel and hit the like button, and also share this channel with your friends and your relatives as well as anyone who is preparing for their upcoming JEE Mains or advanced examination. Okay. So these sessions are basically going to be someone who is currently in class 12 and they are preparing for the upcoming JEE Mains and advanced in 2026. Right. So this particular lecture is going to be on the properties of definite integrals, and we're going to start with the Newton-Leibniz rule, right? So, or the differentiation of the variable limit of definite integral, right? So that is will be the motto of this particular lecture in this particular session, right? And if you haven't watched the previous lecture, my utmost request to all of you, please go back to the channel. Please, you will find the playlist on definite integral. Go and watch the playlist from the start. Okay, please start watching the playlist from the scratch so that you understand and you can get to know the basic part so that you can make a connection with whatever thing is going on in this particular course. Right. So with this all thing, let's get started. So I gave you all two problems to practice as a homework problem. Let's see. Let's start our class from those particular discussion of the homework problem. Right. Okay. So I hope you are doing well, and also please let me know if you have done the solution to these questions or not. Okay. Please let me know if you have done the solution to these questions or not. Okay, so if you have done the solution to the questions are very, very simple, right? So let us try to analyze the first problem, right? So if you look at the first problem over here, first of all, in this problem over here, we have to find out the integral from limit 0 to 2n pi, right? And we have the given function sin x plus cos x, and there is a greatest integer of it, right? There is a greatest integer of it, right? So how do we evaluate that, right? So first of all, let us try to analyze what is the function given inside. So if I try to analyze what is a function that is sin x plus cos x, what I can do over here is that I can try to simplify and I can make this function as, so let us say I take root 2 as common, then it will be 1 upon root 2 sin of x plus over here again 1 upon root 2 cos of x, right? Now how did I get this idea? Now generally in trigonometry we learn this general relation, that is whenever you have like a sin x plus b cos x, the general relation is that whenever you see this kind of expression, try to multiply and divide with square root of a square plus b square. So if you do that, the interesting part over here is that, so after you do this particular kind of transformation or this taking out this common and multiplying on both the sides, multiplying and dividing both the sides. So what the interesting part over here is that you will observe that if you assume in a right angle triangle, if you assume in a right angle triangle, let's say this particular angle is theta and this particular hypotenuse side length is basically given as a square plus b square, and this base is given as a and the hypotenuse is given as b. In this case, you will see that in this triangle I can relate this particular thing to as cos of theta, and similarly this particular relation would be simply transposed to sine of theta, right? Now the biggest advantage of doing or establishing this kind of relation is that I am now in a position to write a general expression for this kind of relation, that is square root of a square plus b square taken out as common multiplied with, now this will become sin x into cos of theta plus cos x into sine of theta. That will be the relation, right? Now, if you recall from your basics of trigonometric formulation, this particular thing is nothing, but I can simply write this as square root of a square plus b square as taken as common multiplied with, now this particular thing can be given as sine of x plus theta, right? So therefore, our ultimate motto to express the sine and cosine term with somewhere like a linear function of sine and cosine to into a specific ratio, that is we are trying to establish this connection to a simple sine term or simply cos term, whichever may be applied over here, right? So similarly in this method over here, So in this case, I can simply relate this result as root 2 times. Now 1 upon root 2 can be written as sine cos of 45 degree, right? So therefore I can write this relation as sine of x plus pi upon 4. Sine of x plus pi upon 4, right? So this will be my given relation, right? So if you try to analyze what is the maximum and the minimum value of this function, this will be maximum is root 2 and the minimum is going to be minus of root 2, right? So this is going to be the maximum and the minimum value, right? And the minimum value, right? Now, when we are putting a greatest integer of it, then you have to remember that minus of root 2 is like minus of 1.414. So that is going to be minus of 2. So if you put greatest integer over this, now don't forget to divide it by root 2 because your ultimate expression is in sin x plus cos x. So if you divide it by root 2, this relation is from minus 1 to, yeah. So this relation is going from minus 1 to plus 1. Okay. I hope this is clear, right? Or did I do any mistake? Okay, oh sorry, very sorry, very sorry. This is a mistake over here that this is the same expression. Okay, sorry, I take back my words. Okay, this is actually the same expression. I cannot cut this root 2 terms over here because this particular expression is a similar expression, that is sin x plus cos x over here, right? This is the same expression. So the maximum and the minimum bound are root 2 and minus plus root 2, right? So this particular, when I take the greatest integer of it, this ratio or greatest of sin x plus cos x, this value will be less than or equal to 1 but will be greater than or equal to minus of 2, right? So this will be the relation of the greatest integer function, right? Now I have to break the intervals into multiple small intervals of x for which I get all these values, right? So if I just do that over here, so you know it very well that after I do sin x plus cos x and greatest integer of it will be equals to minus of 2 when my x is lying between 0 to pi by 2, right? Similarly, it is equal to 0 when my x is lying between 3 pi by 4 to pi by 2, from 2 pi by 2 to 3 pi by 4, right? And it is equal to minus of 1 when x is between pi, 3 pi by 4 and pi, and it is equals to minus of 2 when x is between 3 pi by 2. Sorry, I missed a, so this will be between pi to 3 pi by 2, right? Okay. Similarly, we will have, sorry, this should be 1. Okay, very sorry. Sin x plus cos x is 1 in this interval, right? Similarly, the remaining will be minus 1 when x is lying between 3 pi by 2 to 7 pi by 4, right? And it will be 0 when the x is lying between 2 pi to 7 pi by 4, right? So what I did is that I tried to do the entire cyclic application within this entire limit from 0 to 2 pi, right? And you know that this will be a periodic function, right? This will be a periodic function, so therefore I don't need to do any higher period. Okay, so what we can do, we can simply multiply. So since in the upper limit we have 2n pi, right? So we can simply multiply by n by taking the integration from 0 to 2 pi, right? So therefore, after all doing this particular result, then your integration from 0 to 2n pi for this value, greatest integer of sin x plus cos x dx is gonna be equals to, so within the value 0 to pi by 2, okay, so this is gonna be a bigger sum. Okay, 0 to pi by 2 it is 1, and then it is 0, so I'm neglecting that, and within 3 pi by 4 to pi, it is equal to minus of 1, right? So and then plus then we have pi to 3 pi by 2, we will have pi to 3 pi by 2, we will have minus of 2 dx plus integration from 3 pi by 2 to 7 pi by 4, we have again minus 1 dx and then 0, right? So if you just evaluate this, the result we are going to get is minus of pi. The result that you will get is minus of pi. I hope you can try out to solve it, and but don't forget there is n over here. So this is the result from 0 to 2 pi, right? So to multiply with n also, right? So we have to multiply this particular thing with n. Okay. Okay. So the result to this question is going to be equals to n pi. So result is going to be equals to n pi, because if you analyze, because sin x plus cos x, this particular function because sin x plus cos x, this particular function has a fundamental period of equal to 2 pi. Has a fundamental period because it is a periodic function. And the fundamental period of this particular function is 2 pi over here. I hope this solution is clear to all of you. Is this solution clear to all of you? Please let me know in the live chat. Every one of you, please let me know in the live chat. आस्था दुबे हिंदी में बोलो. Okay. क्या ये समझ में आता है सबको? Is this clear to all of you? क्या ये सबको समझ में आता है? क्या ये चीज सबको समझ में आता है? Please let me know in the live chat. Okay, so this was a really good question, but it's again a very simple question. Only the thing is that आपको क्या करना है यहाँ पे? आपको what you have to do is basically over here is that you have to break the different intervals of x, and for this different interval you have to find out what is the bound of sin x plus cos x, so that you can use the greatest integer over here, right? So if you try to do that in a very simple manner, it is shown over here, right? So I hope if you try to do it by graphical solution, you will also end up getting the same result, right? So you might try to plot the graph of sin x plus cos x, and then you try to analyze the result for greatest integer of that sin x plus cos x term, right? So I hope you can get this result very easily by just plotting the graph, or maybe trying to do a boundary analysis, right? So that basically ends up and gives my the answer to this question. Okay, so that basically gives my answer to this question over here is basically equals to n pi. I hope this is clear, right? Oh, minus of n pi, right? Minus of n pi is going to be the final answer. I hope this is clear to all of you. Please let me know how many of you have tried to solve this question and how many of you got this answer correctly as minus of n pi. Every one of you, please let me know in the live chat how many of you got the answer as minus n pi. How many of you got the answer as minus n pi? Please let me know. Is this clear? Is this clear to all of you? Is this clear to all of you? Okay, so with this part, let's try to analyze the second problem. The second homework problem is, which is much simpler. Okay, so this is much more simpler. What you do over here is that you know that the integration is given from 0 to 25, right? And e to the power x minus greatest integer of x is basically nothing but fractional part of x, right? And you know fractional part of x has a periodicity, has a fundamental period of 1, has a fundamental period of 1. So it is equivalent to 25 times 0 to 1 e to the power x, 0 to 1 e to the power x, right? Now why did I write e to the power x? Because fractional part of x from the in within the interval from 0 to 1, it is simply equal to x, right? It is simply equal to x, so we can just do it over here, and then if I solve it, it is going to be e minus 1 multiplied with 25. So it is going to be equals to 25 times e minus 1. So it's a fairly simple solution, right? So I hope if you have tried to solve this, you must have got the answer as this, right? So this was much simpler rather than this particular question, where you have to actually find the functional value at each of the interval and then you multiply with n, right? Is this clear to all of you? Is this two question clear to all of you? Please let me know in the live chat. Okay, please let me know. Please try to consult. Okay, anyways, if you're having any question, please let me know in the live chat so that I can give you instant solution or answer to your queries, right? Okay, so I hope this is clear, right? Is this part clear to all of you? All right. So with this thing, let's get started with the next upcoming properties, right? And the next important things as well. So you can have multiple questions to practice also, and maybe I can give you some question to practice, right? So let me give you some homework problem to practice also, so that after the class is over, you can practice some of the question in your house, right? So let us say you have a question, and this is a very interesting question. Let us say you have a function g of x, which is a continuous function, right? So let us say you have a g of x, which is a continuous function, okay, which is a continuous function, continuous and differentiable function, okay, continuous and differentiable function, such that within the interval from 0 to 2, if you definitely integrate it, and the result inside it is basically going from root 2 to it is going from root 2 to root under 5 by 2, right? And we have greatest integer of x square minus 3, and then we have dx, and this particular thing multiplied with g of x dx, which is equals to 0, right? Which is equal to 0, and then g of x is equals to 0 when x belongs to 0 to 2. So in this interval from 0 to 2, g of x is equal to 0. G of x is equal to 0. Okay, so sorry. The question is basically to say that in this interval of x belonging to 0 to 2, what are the roots of this function g of x equal to 0? So you have to tell me the answer for how many roots will be there for this g of x equal to 0 within this interval from x going from 0 to 2. So this is the very first question that I want all of you to try to solve it. Okay, please try to solve this question. This is a very interesting question, right? Now let's take another homework problem. I hope you have taken down this question. Please take a screenshot. Okay, so this is a very interesting problem, and the second problem that I want all of you to try is this problem. Yeah, so the question is integral from 0 to 2 x plus 14 and greatest integer of that, and then we have x upon 2 fractional part of this dx is equals to integration from 0 to greatest integer of x. Okay, greatest of x, and then we have 0 to fractional part of x, and then we have greatest integer of x plus 14 dx, right? So if these two integrals are equal, where this square bracket denotes the greatest integer function, that is shortly written as GIF, and this curly bracket denotes fractional part function, okay, FPF or fractional part function, right? So these are the two important function representation which you have already studied in the chapter of function, right? And if you haven't studied function, you can always visit our playlist, right? In this particular channel, you can find out all the sessions that have been taken so far on functions. Okay, so if you haven't prepared function, please go back to those lectures and try to prepare function and then come back to this lecture. That will actually help you out to understand the lectures as well, right? Or maybe to solve the question as well. So if these things are equal, you have to find out then what is the value of x. Find x, okay? Find x for which this particular equation is satisfied, okay? Please find the value of x for which, or find the range of the x, okay? Maybe you will not be able to find the exact value, maybe you will be able to find the range of the x, right? So please try to find out what is the range of the x that is satisfying this particular problem, okay? Is this clear to all of you? Please take a screenshot. JEE aspirant, hello. Okay, please take a screenshot of this question. Okay, please take a screenshot and let's proceed with the next property, right? So the next property that we are going to discuss today in this important lecture is the properties, or something what we called as Leibniz rule for differentiation under the integral sign, right? So the next property, I hope it will be property number 9, right? So the next property is basically also known as the Leibniz rule for differentiation. Okay, rule for differentiation under the integral sign. Okay, Leibniz rule for differentiation under the integral sign, right? So this is our topic for today's session, right? So what do you mean by differentiation under the integral sign? Let's try to analyze. And in this particular session, I'm going to only restrict myself to only one variable function, right? I'm not going to take the case for multiple dimension functions because they are too difficult to analyze in this particular scope of this class, right? So let's say I have a simple function. Let's just give me a second. Yeah. So let's say I take a very simple function. So let's say if the function I have, like let us say I have phi of x and psi of x are two functions which are defined on the interval from a to b, and are continuous and differentiable, continuous on the closed interval and differentiable on the open interval, right? So let us say there is some value x which is basically belonging between this number A to B, which is basically lying between A to B. And so if we have this formulation of function and the f of t function is continuous on, so let us have another function f of t which is continuous on the interval phi of a to phi of b. Let us have this particular formulation, right? So if we have this formulation over here, then then when we try to differentiate the result going from phi of x to psi of x for the function f of t dt, and we want to differentiate this function, then as per the Newton-Leibniz rule, it says that the derivative of this kind of integral is going to be equal to first of all you differentiate the upper limit, right, and multiply with function of value at the upper limit, right, minus differentiate the lower limit and then multiply with the value at the lower limit, right? So this is what is called as the Newton-Leibniz rule or Leibniz rule for differentiation under the integral sign, right? Now please don't ask me how the proof of this particular theorem comes about, because the proof of this theorem is beyond the scope of this lecture, right? So the scope of the lecture is basically targeting especially the upcoming JEE Mains and advanced examination. So it is more obvious to know the application of this particular formula than knowing how the formula comes up, right? So if you are very curious to know how the formula comes up, I can refer you some of the standard textbook in differential calculus. You can follow those textbook and you can definitely get some close bound analytical development for these kinds of results, or maybe you can get the proof of these results, right? So you can take up any standard book on real analysis, or maybe any standard book on differential calculus. They will actually suffice your need, right? Okay, so I hope that is clear. Is this clear to all of you? Right. So if this formulation is clear, let's try to see how we're going to apply these two questions, right? So if I take a very simple problem, let me take a very simple problem to illustrate. Let us say I have a given integration from 0 to x square for the function cos t dt, right? And in the cos t square, right? Let us say I have this kind of expression, and in the question it is said that this is some function of x, this is some function of x, and please try to differentiate this function of x, right? So if I have to differentiate this particular value with respect to x, right? So if I have to differentiate this particular value with respect to x, so by using this application of this Leibniz rule or Leibniz theorem for differentiation, so if I follow this result over here, what I can see is that first of all differentiate the upper limit. So the upper limit over here is x square, so derivative of x square with respect to x, and then multiply the value of the function at the upper limit, right? So that is going to be a cos of x to the power 4, right? And then minus differentiate the lower limit, that is going to be 0, and then multiply with the function value at the lower limit, right? So if we just evaluate this expression, it is going to be 2x times cos of x to the power 4. I hope this result is clear, right? So the derivative of this kind of integral is going to be simply as 2x times cos to the power cos of x to the power 4, right? Cos of x to the power 4. I hope this question is clear to all of you, right? I hope this question is clear, right? Now you can, now after this particular class is done, you can now solve those questions of limit where you have seen that in the limit problems that some of the numerator used to have like a variable definite integral, right? So those questions of limit can now be easily done just by simply using the L'Hopital rule, right? All right. So I assume this is clear to all of you. right? So if this result is clear, I want to give you some homework problem to practice along with this particular result. The question that you can try to practice is that now I can club multiple concepts from, especially from the concept of application of derivative into this question as well. So the question can be find the points of maxima and minima. Okay, you have to find both the points of maxima and minima for the given function, 0 to x square. Okay, I will write it again, maybe it will be clumsy. X square, 0 to x square, right? And we have t square minus 5t plus 4, t square minus 5t plus 4 whole divided by 2 plus 2 plus e to the power t, right? So we have this particular function. You have to tell me that what will be the point of maxima and minima for this given function, right? So please try to find out the maxima and minima point from this particular function, and don't forget this x square, right? The derivative limit is going from 0 to x square, right? So this is the first question that you can try to solve as a homework problem after you learn this new Leibniz rule of derivative, right? I hope this is clear. Now the second problem, now this is types of questions are repeated many times in the JEE advanced problems as well, and sometimes and recently, in the JEE Mains also these kinds of questions are getting repeated. That is, if you have, let us say, a differential integral equation for definite integral within the limit pi by 3 to x, and the given function is basically 3 minus sine square t dt plus integral from 0 to y we have cos t dt is equals to 0. Then find dy by dx. Okay, then find dy by dx. Okay, so this is another important question, another important set of question. Please try to solve this question as well in order to understand this particular theorem of Leibniz rule of derivative under the integral sign, right? So if you try to solve these all questions, I think it will be helpful to all of you, right? Hi Divine Gaming 111. Are you telling me the answer of the question? Okay. So with this particular thing, I hope the lecture is clear to all of you. So I hope this particular property makes sense to you, and please try to remember this property because this is going to be very, very useful, especially for the solving questions on different varieties of questions, especially when differentiation is involved for integrals, right? So please make sure that you remember this. Okay. So we will see of the solution or the how you can approach this question in the next class. So if you have, please try to solve this question, and once you get the solution, please let me know the solution in the comment box. Okay, so you are saying me the answer for the first question is 1. Okay, so this first question, right? So this was the first homework problem, right? The question or this first homework problem is not 1. Okay, let me check. Maybe it is. Yeah, it is not 1. Okay, it is not exactly one root. Okay, one root is correct, but it is not exactly one root. You might have more than one root also, right? That is actually the correct answer to this question. Okay. Okay. Don't worry. We're gonna see the answer to these questions. Okay. Try it upon. Okay. Give it another try. Think about the steps, and maybe some of the steps you can find out that how you can get multiple answers, right? So that is also possible. Very possible. Okay. Maxima, minima. Oh, all right. So you joined the lecture at the late end, right? So you wanted to say me the answer for the maximum and the minima. Okay, the point of maxima, no, you won't have only one point. Okay, you have multiple points. Please tell me the entire answer, then I will tell you the answers. Okay, so in this question, the point of maxima are -1 and 1, and point of minima are -2, 0 and 1, 0 and 2, 0 and 2, right? So there will be total 5 critical points, right? Total 5 critical points, but f dash of x is changing the sign, right? So please try to solve it again. Okay, maybe you are doing some mistakes in the question. Okay, try to solve it, you will get the solution. Okay, so with this, thank you for your time for joining this particular session, and I hope this lecture helped you in understanding the basic concepts, and also by utilizing these properties, you can try to solve now the questions of the limits, which were basically a difficulty when you were trying to solve the questions of limit, which is having some definite integral with a variable limit, right? So those questions now you can try to solve, and with this, I would conclude my session over here, and thank you for your patience and your timing, and hope to see you soon in the upcoming classes. So again, we're going to take up live classes in the tomorrow and the day after tomorrow, where we're going to finish up the entire chapter of definite integral, right? So with these things, I wish you all the best and keep studying and